Okay, let's kind of handle this towards the end of class, because I'm probably gonna have to redirect you to my colleague to see what you need to do next. My earlier class. Let me make sure I'm streaming, and let's start off here. And who is that?
Oh, it says add a code. Now it says add a code.
You need a code?
Yeah.
I never sent you a code. Because I still think I feel like I should point you towards. Just remind me towards the end of class, and we'll get you squared away. We can't do that right now, though.
Alright, I got you.
This is the actual lab. Okay. And let me do this. Okay, so we'll start here. So our exam 2 should open up tonight. I think last time we took some time with section 1.5. I think today I'm gonna just work on section 1.4. Right? So we're just gonna start there today. Okay, and actually I think I need to kind of do one other thing here. I want to preview. I can't get that straight. Anyway, and we need to change this to this. Yes. Okay. So we're gonna work section 1.4, and I'll just kind of flip between Pearson and my tablet. Okay. Let me check the chat one more time. Oops. Let's go back. Let's check the chat here. Yeah, it's okay. Yeah. So again, I'm probably gonna have to redirect you guys to my colleague. It's Dr. Lamar is who you want to. It's Dr. Lamar in the mathematics department. That's who you want to reach out to, and she'll know exactly what you need to do. Okay. So just in the effort to work on different problem sets, I'm going to skip this one because I did it with my other students, and I'm going to defer you to my YouTube video from earlier for this question. Not this one. I think I took it. I gave him. Let me just check and make sure. All right, so let me try to choose one that I haven't worked. That I didn't just work. We did a good amount of these too. Or if you have a request, just let me know, and I'll do what was requested. If nothing's requested, I'm just going to try to choose ones that I didn't just do. Okay, let's do this one. Right? Okay, we'll start here because we did one similar, but it's okay. All right. Check one other thing. Yeah, let me reboot you. Let's have about that time to type this title up. This is week 8. This is exam 2 study session. Sections 1.4, 1.6. Algebra. This class meets Tuesday, Thursday. All right. So this one, so let's see. We're working in section 1.4, a library of functions. Okay. This is question number 8 from this homework, and it comes from section 1.4, question 27, in the back of that section. And it's asking us to determine whether this is even, odd, or neither. So I'm just taking notes on the one that we're working on. And we have this f of x equals x to the power of 9 plus x to the power of 5. Right? X to the 9 plus x to the 5. Okay, let's hop over and see the tablet. Okay, so to do a quick recap, even, odd, or neither, the definition of a function being even is as follows. When we do f of negative x, we get back the original. All right? That's the definition of a function being even. The definition of a function being odd means when we do f of negative x, we get negative of the original. That's the definition of a function being odd. So this is what we're going to use to test even, odd, symmetry, even, odd, or neither in this case. Okay. So then I'm going to rewrite my f of x. First, I'm going to replace each x with a blank set of parentheses. All right. And then inside each blank parentheses, I'm going to use my negative x. Okay. So then if we do this, if we have an odd number of negatives, the final result is going to be negative. An odd number of negatives, the final result is going to be negative. We can factor out a negative from both of these guys, and we'll get this. And notice that this is indeed negative of the original. So we have f of negative x equals negative f of x. That means this function is odd. Odd is the same as origin symmetry. All right, so let's hop over and see how do we do. Wait a minute, did that switch automatically? It surely does. It seems like it works without me having to go there. Oh, that's pretty interesting. Oh, did I lose my page? It looks like I lost my page. Can I go back? Shoot. We may have lost the one that we were working on. Let's preview. And we're working on number 8. Oh, I get what's going on because that's the shortcut there. I see. Okay. We'll work that out. Okay, so we're working at Pearson right now. Let me see. We have the same thing. This has a similar argument. It's not the exact same, but it's a similar argument, so I'm going to go with odd. Okay. Let's try the next one. Okay, let's do this one. This one looks interesting. Again, the last one. Alright, so this is number 9, right? Are you slowing down? Number 9, yeah. Let's just reboot it. Maybe it'll help if I close out some of these other items. Okay. And this comes from section 1-4, question number 33. Okay. It asks us to determine whether it's even, odd, or neither. And we have this f of x equals, now we got this x squared minus 8x over 9x to the 4 plus 2. Okay? Let's hop here. Let me see if that works. It did work. Okay, that's good to know. I think I could do it. Okay? So let me write the definition of even, odd, or neither again. So again, even, a function being even means when we do f of negative x, we get back f of x. A function being odd means when we do f of negative x, we get negative of the original, right? So then if we start with our f of x, I'm going to replace each x with a, first I'm going to start with a blank set of parentheses. So we get x squared minus 8x over 9x to the 4 plus 2, right? And then for each blank parentheses, I'm going to replace each x with a negative x. Negative x, negative x, negative x, and negative x, right? Now we're just going to simplify. So if we simplify, that's going to become a positive x squared. Double negative becomes a positive 8x over 9x to the 4 plus 2. Is this the original? Nope. Can we factor out a negative to get back to the original? No. Nope. So I'm going to say neither. This one is neither even nor odd. For a moment there, I thought it was even. It looked like we were about to satisfy the conditions for it to be even, but it didn't work out. Okay. So let's hop here. Just check it real quick. It looks good. Okay. So we said that it's neither even nor odd. Okay. Let me check the chat really quick to see if there are any questions. And another thing, feel free to unmute yourself if you have a question as well. If you just don't want to type it in the chat. I'm streaming. I should be streaming to YouTube. Yeah, I'm streaming it to my YouTube. All right. So, yeah, I'm streaming it directly. If you wanted to send me a problem from Alex, screenshot it and email it to me, and we can talk about it now. Yeah, you can send me problems from Alex. So. Okay. Oh no, what did I just close? I closed something that I didn't want to close. All right, let's close this out and let's preview. So let's go like this, preview. I need you to be full screen. Let's hop over here and let's switch this from waiting room. That's fine. Maybe if I put it here, from the waiting room to Pearson. Right? Let's see. Okay, so we just finished, that was what, number 9? I think I did 10 with my other class, so I'm going to go to number 11. Okay, I guess we can do this because it looks a little bit different. I mean, this is honestly the last one that we did. And I'm intentionally skipping these because these should be on my YouTube channel. I literally just did them, and so I'm going to defer you to those. If you want to see any of these worked out that I'm skipping, just watch the classes right before this one, and you can get all of this stuff. Okay, let's do this one. So it says the graph to the right. Use the graph to find each of the following. So first it asks for the domain. Domain is going to be the very left to the very right. Now, I know this one doesn't show any arrows, but this one, you have to use context clues. This looks like a log function because it looks like we have a vertical asymptote. So if it's a log function, the very left, in this case, the way it's drawn, would be negative infinity. And the very right is going to be the y-axis, right? It looks like it has a vertical asymptote. So the very left, let me think about it. The very left is negative infinity. Yep. Up until 0, and we never actually reach 0. There's an asymptote there, so we get really, really close to 0, so I'm going to go with this. Okay. The very bottom to the very top, the lowest y value, it goes all the way down to negative infinity, and it goes up to positive infinity. All right, so we're going to say from negative infinity up to positive infinity. Okay. There are more parts. Let's see what's next. X and Y intercepts. Okay, X-intercept. They gave it to us. We just look at it. The X-intercept of the function. What about Y-intercept? There are no Y-intercepts. So there are no Y-intercepts, but the X-intercept is going to be negative 1, 0. Negative 1, 0. Okay. X-intercept. Is that not what I typed? No Y-intercept to X-intercept. What's wrong with negative 1, 0? And in it, duh, it's the formatting. I always forget that they don't want the ordered pair. They just want negative 1. Okay. Herbert, 3 parts remaining. Can we just hit enter? That would have been nice. Increasing, decreasing, or constant. So as we trace it left to right, it's going up. So the function is increasing. No, it's not that one. It's going to be, it's never decreasing, and it's increasing. Interval notation, so the domain. The domain in this case, it goes from negative infinity up until 0. And again, we put a parentheses on the 0 because we don't actually reach the 0. There's a vertical asymptote. This is like the graph of a log function. It's not the, it definitely has some manipulation, but it's generally like, it's like a negative was multiplied on the inside. All right, let's keep going. Constant is never constant, so we're gonna go with B. Even, odd, or neither. Even means y-axis symmetry. There's no y-axis symmetry. Odd means origin symmetry. There's no origin symmetry, and so this one should be neither.
I have a question.
Go ahead.
So, on the homework, there's a problem where you have to determine whether a function is increasing or decreasing.
You know what
number? It gives you a problem like.
You know what number?
I'm sorry, what?
Is it in this section?
Yes. Yeah, it's in this section. I'm not sure it'll show like the same like numbers since they like differ.
Click on the Ask My Instructor, and it'll come to my email, and I'll pull it up. Yeah, it'll send me a screenshot. I'll pull it up right now. And then that way, it should be your same numbers, and we can work through the one that you're working on. Let me know once you sent it.
I think I just sent it.
Okay, let me see what do I have on my end. Let me hop over here to make sure this is displaying the right thing. Okay. Let's go here. Is this Mr. Johnson? Oh, this is the Alex problem. Simplify. Okay, we'll go ahead and include this one as well. Let's copy. Let me just save it. I guess it'll be more simple to just save it. It should be here. Because I know I didn't use my other email. Who used the X My Instructor?
I did.
Mr. Washington. I don't see it. Let me check another. I got the screenshot from Alex. I'm about to pull that one up. It's usually like pretty quick. Did you send the email? Because it should have opened up the email browser and actually to send the email.
Okay, I think I sent it. Yeah.
Okay, so I'm going to give that a moment to load, and while that's loading, I'm going to work on this one from Alex. Alex, let's go here. Let's hop here, here. So let me load the one from Alex and give that other one a chance to. This is the one from Alex. Let's go like this. Crop. Okay. So this question comes in from Alex, and it says it asks us to simplify. I know it's a little blurry, but that's okay. We have what we need, right? So let's start by getting a copy of the original. So let me see. We have this 12. It says u to the 5th, w to the 6th, divided by, we got this 16u cubed minus 20u to the 6th, x to the 3, right? So we want to simplify. So this is a factoring example, right? We want to say, okay, is there a greatest common factor? Is there anything that's common to everything, right? So it looks like they all have at least a u. They're all at least even. I think they're all divisible by 4. So they all have a 4u. Okay. So we have a 4, we have u, and I think that's it, right? They don't all have x, they don't all have w. And then we take the smallest exponent on the u. The smallest exponent is u to the power of 3, right? So we can factor out that 4u cubed from everything. Let me move over here. So if we factor out 4u cubed from the top, that leaves us with 3u squared w to the 6th. And on bottom, if we have this 4u cubed, it leaves us with 4 minus 5u cubed x cubed, right? So then this can cancel this, and it looks like the final result is this guy. Here, let's write it this way. 4 minus 5u cubed x cubed under 3u squared w to the 6th. So Alex, so that question that came in from Alex, this is what I got. There is nothing common to everything else. Let me see if I can pull up this. That was this one. Oh, we can do the waiting room, I guess. Let me hop back over here. Okay, so it came in now, Mr. Washington. I'm just going to pull it up. Hey, Google, turn the fan off. So it says, oh, this is number 13. Oh, that's, yeah, okay, let me see. Intervals over which the function is constant. Oh, so let me hop like this. So that's going to be here. All right, so this comes to section 1.4, question number 13. And it's asking us information about this function. We have f of x equals 4x minus 3. You can actually graph that, right? That one should be a straight line. You can use a graphing calculator, but you should be able to graph that one fairly easily. The y-intercept is going to be -3. It has a positive slope of 4. So then when it asks over what interval is the function constant, if it's a diagonal line with a positive slope and the y-intercept of -3, it never becomes constant. It's always increasing because it has a positive slope, right? So that at least part B would be no solution.
Okay, but for the first part, part A,
okay,
like I knew it was increasing. It's just that I wasn't very clear on why it was negative infinity to infinity rather than that to like 4.
I would look at the graph, right? This is a line. So if we look at the graph, if we graph the line, we asking ourselves for domain. So it's increasing over the whole domain, and the domain is basically the very left to the very right. How far left does this graph go? No matter how far left we go, we can find the corresponding y. No matter how far right we go on the x-axis, we can find the corresponding y. So this comes out. This comes out of the domain of a linear function.
All right.
Is that okay?
Yeah. Thank you.
Yeah. Okay. Let's see if we can hop back. Oh, we weren't working here. Let's go here. Let's hop back to Pearson. Let me make sure it's showing Pearson. Okay. Did we finish this one? Let's do the next one. 23. All right. Let me check the chat really quickly. Chat. I got the Alex one. Yeah. Okay. Let me check. I don't think it's anybody in the room. Monty, I'm gonna have to suppress your stuff because you don't be doing Dokkan battle anymore. I'll be playing those other games. Anyway, okay. Okay, let f of x be this. We're asked to find these and then sketch the graph, right? Let's do, actually. Oh, need to load that back. Let's go, we're doing Pearson. Okay, I think that should be okay. So let f of x be this. Okay, so if we're doing f of 2, let me kind of... If we're doing f of 2, right? This is saying when x is 2, do we use line 1 or do we use line 2? Right? If x is 2, do we use line 1 or do we use line 2? So line 1 says use this line if x is bigger than or equal to 5. Use this line if x is less than 5. Well, if x is 2, x is indeed strictly less than 5, so the answer is going to be 5, right? So this one is just going to be 5. Okay. Now, if x is 5, well, this one says use this line if x is greater than or equal to 5, right? 5 is equal to 5, so then the answer is going to be x, and x in this case is 5. Okay. Now, if x is 6, it's greater than or equal to 5, so we're going to use the first line, and we just submit whatever our x is. In this case, our x is 6, so we're going to submit 6. Okay. And then sketch the graph, right? So to the left of 5 is going to be a horizontal line of y equals 5. But to the right of 5 is going to be a diagonal line of y equals x, right? So the left is horizontal and the right is a positive diagonal. So to the left of 5, and it's actually filled in because when x is 5, y is 5. So this is the one that causes it to fill in. Yeah. Only reason I'm not choosing B because that's open and I think it's supposed to be filled in. And I think it's D, right? It's constant to the left and the diagonal line to the right. I'm going to go with this one. Okay. All right. Let me suppress the chat. Whatever. Okay. This one might help if we graph it first. So I think I might graph this one first and then answer the question. I think that'll help. I want to say our graphic calculators can graph piecewise functions. I would just do a Google search on how to graph a piecewise function on whatever calculator you're using, whatever graphing calculator you're using. You can also use things like GeoGebra. GeoGebra is a free online tool that allows you to create digital graphs, right? So we can type this piecewise function into GeoGebra, and it'll spit out the graph for us. Okay, so let me start by doing this by hand. This is number 14. This is number, come on, 14. It comes from section 1-4, question 47. The first line says we have this 4 plus x if x is strictly less than 0. This other one is x squared if x is greater than or equal to 0. And this is f of x. Okay. Let's hop over here, and let's go to this one. This should be okay. Okay. So let's start by graphing this. So this is all centered around x equal to 0, right? So I'm gonna start like with my x-axis. Here's my this is my positive x in this direction, and then this is gonna be my positive y in this direction. We got 1, 2, 3, 4, 5, 6. 2, 3, 4. Let me just copy and paste these. Copy, paste. That works. And then copy, paste. Okay. This is going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 5, 6. This is the origin, and these are my negative values. Negative values. Okay. So now, all we do to graph a piecewise, we just graph it like normal, and then we erase the part that we don't need, right? Anybody got a favorite color? Anybody feeling the color? Okay, let me check the chat. All right, since I don't see a color, I'm feeling purple, so feeling like royalty. So I'm gonna choose purple. So I'm gonna do this first line in purple. So this guy. Actually, let's do undo style. Okay, we're gonna do that one in purple. Let's impress the chat. Okay. So if we were to graph that in purple, that's basically y equals x plus 4, right? So the y-intercept is 4. It has a positive slope. And then it's basically like this. Okay. That's that graph based on what we have access to. And then I don't think let me see if there's anybody here that comes color. Let's do orange. So we'll do this one. Okay. So if we graph that one like normal, that's just x squared, right? So we have the origin, we have 1, 1, we have negative 1, 1, we have 2, 4, and we're going to also have negative 2, 4. Right? And then so that graph, like normal, maybe something like, but then there's an added stipulation. Okay. So now with piecewise function, we have to erase the part that we don't need, right? So the first one, the purple only applies when x is to the left of 0, right? X is strictly less than 0, so we need to kind of clean this up a bit. So we're going to get rid of that. Okay, oh, I got it. And then we need to introduce something like this. Style, fill, we want no fill. Actually, we're going to fill it with white. Let's kind of throw things off a little bit. We'll just do this to kind of clean it up. The whole point is that's supposed to be an open circle, right? Okay, that's the gist of it anyway. Okay, so what we did with the first one, we just kept the left part of the purple graph, right? I guess I could have just did blank if I did all that. Sorry guys, I'm just being nitpicky for no reason. Okay, so that's the purple. Now we need to go back and adjust the orange, right? For the orange, it says that we keep that graph as long as x is greater than or equal to 0. So that means we're going to keep the right-hand side of that graph. So I need to get rid of the left-hand part, right? So what I'm going to do, I'm going to take this. I'm going to partial. I want to cut it about there. I'm going to do the whole, get rid of this. And I'm keeping that one. And let's put it back. So again, we kept the right and we got rid of the left, right? That one's going to be a filled-in circle. Let me just copy and paste. And let's go style, orange, stroke is orange. Okay, right? So then those two pieces together, this is the final product. The purple says graph it like normal, but keep the left-hand part. The orange says graph it like normal, but keep the right-hand part. And so then we finish the graph like this, okay? So then, let's hop back over to Pearson. Now, if, let me hop back here again. So if this is our image, we want to find the domain of this. If we were to take this and smush it onto the x-axis, right? The domain is the very left to the very right. No matter how far left we go, so let me do, what color have that? This color might pop. So if we're going to do the very left to the very right, style, we need some thickums, kind of like this, a little bit right there, right? So, and let's actually change that style as well. We're going to do, let's do this. Okay. So with this, no matter how far left we go, we can, on the x-axis, we can find the corresponding y, right? So for every x, we can find the corresponding y. So the far left will be negative infinity. The only point in question is here. Now, if we smush this to the x-axis, I want to say every x is accounted for. Even though it seems like there's a gap, you know, when x is 0 is defined, and any point to the left is defined, any point to the right is defined. So the domain here, I would say, I will go all rails, negative infinity to infinity. Okay. Let's hop back over to Pearson. And we're going to say every x is accounted for over the whole row line. So we're going to say all rows. Yeah, the third one. Second one. What time does class let out?
5:05.
It is 5:05? It's not 5:15? Okay. All right. Then the next one asks us to find X-intercepts. All right. So the X-intercepts occur when y is 0. Let's hop back over to our graph. So when y is 0, it looks like we have two X-intercepts. When x is -4 and when x is 0, right? When y is 0, that occurs. But wait a minute. Yeah, I think we're okay, right? The x-intercepts. -4 and 0. Okay, -4 and 0. Okay, let's do -4 and 0. -4, 0. The y-intercepts, we only have one y-intercept, and that's the origin. I'm just going to say 0. Okay, and it looks like we got graph B, right? Okay. All right. The range, based on the graph, right? So if this is correct, remember, the very bottom, it goes down to -infinity and up to +infinity, and every y is accounted for. We have some repeats, but we can find the corresponding x for every y. It's not 1-to-1, but it is a function. The range we said was all reals, very bottom to the very top. Okay. Let me check the chat real quick. Check the chat. Okay, it's looking good. Nothing like there's any request there. I'm going to go on to the next question. Sketch the graph. Okay. So this one is absolute value, right? But this only applies when x is between -2 and 1. And then it's going to be the square root function when x is greater than or equal to 1. All right? So it should be a v as x goes from -2 to 1. Absolute value of 1 is 1, square root of 1 is 1, so they should be filled in. Well, this one is in the v, so it can't be this one. This one's not behaving like a square root function. This is more like a quadratic, so it's not this one. This one is not defined when x is 1, so it should not be this one. The only one by deduction is going to be D. Let's go with this one. Okay. The domain, right? So if we're looking at the graph, the very left, what is this, -2, and the very right is +infinity, and all the x's are accounted for. So -2 to infinity, it should be C. Ho, ho, ho. Merry Christmas. Oh. I'm excited about this semester. This is interesting. Like, I've been working at Morehouse off and on since about 2012. Like, I worked for about 5 or 6 years for Morehouse full time. I left and came back. I came back as an adjunct. But in all the time as a student and as a professor at Morehouse, we never were done before Thanksgiving. I'm geeked. I don't know about you guys, but I'm geeked. So, like, by the time we hit Thanksgiving, we're gonna be done with Morehouse all the way until like January or something. That's a lot to me. That's pretty big. I told I was about to make an inappropriate joke. What's the range? The very bottom to the very top, right? Let's see. The range. Okay. If we look at this graph, how far down does the graph go? The lowest y value is y equals 0 here. This is the square root function, so the range there should go all the way to +infinity. So this one is going to go from 0 to +infinity. 0 to +infinity. This one. Okay. Let me check the chat. All right, we're looking good. Let's go on to the next question. Got to leave some questions for my next class. It's okay. We're asked to find the average rate of change of this function from one point to another, from one x value to another of this function. Again, for our discussion, average rate of change is just the slope. They're basically saying find the slope as x goes from 0 to 9. That's all it's saying, right? So let's take some notes and find the slopes. Taking notes and finding slopes, writing checks and snapping necks and cashing checks. I'm trying to get one more in there. Anyway, I'm totally just bugging. I'm ready to get up from this thing and move around and go do stuff. But, we need to do what we need to do. Okay, so this is question number 16. This is number 16. This comes from section 1.4, question 53. It says average. I'm gonna just take some notes. Average rate of rate of change. Basically talking about the slope. I'm gonna put this in my notation. Basically saying find the slope. And then we're also given f of x is 4x. And as x1 goes from 0 to x2 being 9. Okay. Let me show you the notes that I just took. So we can hop here. I want to show this. It should be good. I'm going to trust it. I didn't even realize those shortcuts worked across the whole platform, which is awesome. It's 444. All right. Energy stability. Okay, so we're finding the slope, right? So let's find these ordered pairs. Let's find these ordered pairs, right? So when x is 0, it looks like what? Y is also 0. When x is 9, what's 9? Was it 36? Y is 36, right? And then, so once I have my ordered pairs, I usually like to go x1, y1, x2, y2. Okay. Also, let's go ahead and use the slope formula. Slope formula is y2 minus y1 over x2 minus x1. Okay. So let's see, our y2 is 36 minus y1, which is 0. 9 minus 0, right? What is that, 4? Oh, duh. We have to calculate the slope. We have the slope. The slope is right there. Totally just ignore that. But it wasn't bad practice. It just made us stronger. So that's the slope. Oh, average rate of change. Oh, we could have looked at it. I did all these calculations. Ugh. The answer was right there from the rip. Average rate of change was the slope. The slope was right there from the start. Moving too fast. Okay, let's hop back over to Pearson. Let me check. Looks good. So the average rate of change, we didn't even have to do any calculations. If we realized that it was a linear function and the slope was 4, all we wanted was the slope anyway. That's what happens when you move fast. You're not as clean. Okay, g of x, find the average rate of change. This one does not have a slope, so we're going to find it. This one we actually do need to calculate the slope. So, average rate of change, yeah. So we're going to do the same thing. Again, the last one was linear, so the slope was showing from the rip. This one is not linear, so we need to do pretty much redo what we just did. So this is number 17. This comes from section 1.4, question 55. Okay. Basically the same stuff, so let me copy this. We can paste it here. And then we're given that g of x equals 5x squared minus 9 as x, find the average rate of change as x changes from -8 to 6. As x changes from -8 to 6. All right, let's hop over to the tablet, which is this one. All right. I could use a second monitor here. No, I'll figure that out later. All right, I'm just going to do the same thing that I just did. All right, so first let me list out my ordered pairs. So when x is -8, let's find the corresponding y. 8 times 8 is what? 64 times 5? I don't feel like doing all that. Hey Google, what's 64 times 5? 300, 320. So that's going to be 311. All right, let's just go with it. So when x is -8, let me check. Hey Google, what's 5 times -8 times -8 minus 9? Okay. So then when x is 6, that's 36 times 5. That's 150 plus 30 is 180, 171. Okay, I'm just going to check on my calculator really quickly. Hey Google, what's 5 times 6 minus 9? All right, so that looks good. All right, so we have these ordered pairs. Now we just find the slope. Average rate of change, just the slope between the points. So again, slope is going to be, I mean, to be more precise, it should really be f of b minus f of a, but it's the same thing. I'll just write it like this: f of b minus f of a over b minus a, right? But it's the same as the slope. So the second one, that's going to be, all right, so we'll do 171 minus 311 over 6 minus a negative 8. Okay, we keep going. If there were 200, that would be 111, 131 plus 9 is 140, right? 14, yeah, 140. So the top is going to be 140 divided by 6 is 12, 13, 14. What is that, 10? 10. 10 units. X is going to rise, right? Y is going to change by 10 units every time X changes by 1. Okay, so let's hop here and like this. I'm just going to put 10. Oh, let me see. What did we do wrong? 140. That should be 10. That's it. Oh, is that not 40? That's 140. What did we do wrong? Remember, yeah, we got that. Let me check it one more time. 5x squared minus 9. 64. 320. 311. 36. It's 50. I mean, sorry, 150. Sorry, let me just do this. Hey, Google, what's 5 times 6 times 6 minus 9? Hey, Siri, what's 5 times 6 times 6 minus 9?
5 times 6 times 6 minus 9 is 171.
Oh, wait a minute. I see it. I see an error. I found something. Okay. 171 minus 311 is negative 140. So that makes this a negative 10. Okay, let's try negative 10. I was like, and I saw that when I was writing it, and I just forgot to write it. We're going to hit negative. Awesome sauce. Man, as it happens, oh, I forgot to carry the negative, and then it makes your account go from positive a gazillion to minus a gazillion, and it wreaks all this havoc. Right? So that stuff is important. So it seems trivial, but that's like the difference. It's like night and day, the difference between your account being plus 10,000 and minus 10,000. All right? We owe you versus you owe me kind of thing. So it's not really trivial. It just seems like that. So, like this, all right? Okay. What's the time? We got time for maybe one more. Let me check the chat to see if there have been any requests. Negative 10, right? Yeah, I should have just checked the chat. Okay, so but we found it. Let's just do the next one. This will be the last one. Find and simplify the difference quotient, of course. Difference quotient will be the last one. Let's go ahead and do it. We got time. All right, so this is number 18. So number 18, this comes from 1457. This is around difference quotient. Okay. We're going to use the form f of x minus, let me see, a equals 4, right? Okay. We're going to use f of x minus f of a. It's doing a little bit different than the way I'm used to doing it. That's okay. X minus a Again, x is not equal to a. And we're also given more information. It says that f of x is 2x squared plus x, and it says that a is equal to 4. This must be for the next class. Let me lock it so they don't interrupt us a bunch. All right. So they give us that a is 4. So let's plug in a equal to 4 and see what happens. All right. So then what we're going to do f of x minus, let me think about it. Yeah. F of 4 over x minus 4. Let's simplify this. Okay. So then this is going to be f of x, which is 2x squared plus x minus f of 4, 2 times 4 squared plus 4 over x minus 4. Okay, let's keep going. 2x squared plus x, that's 4 times 4 is 16, times 2 is 32, plus 4 is 36. Okay, let's keep going. So we want to, let's factor the top, right? There's no GCF, so we're looking for two numbers that multiply to give us 72, right? Two numbers that multiply to give us a negative 72 and add to give us 1. Let's go down the list, right? It's probably going to be towards the end of our list, but let's just go down the list, right? 72 is what? 9 and 8, right? So 9 times 8. So then 8 is 2 times 2 times 2. 9 is 3 times 3, right? 36 was 4 times 9 times 2. 4, 9, 2. Okay. So now we're going to go through the list and we're going to stop at the line that adds up to 1. Okay. So negative 1 is 72, but that adds up to 71, so that's no good. We can do 2 and 36, but that doesn't work. We can do 3. Now watch this. If we use this 3, we have what? 24 left over. So that adds up to 19, so that's no good. We can do 4. If we do 4, if we've used these guys, we have what? 9 times 2 is 18. There's 18 left over. That adds up to 14, so we're going to keep going. We can't do 5 because we don't have a 5 anywhere in this list. We can do 6 though. We have 6 right here. If we use this 6, 3 times 4 is 12. So we have 6 times 12. That adds up to 6. So we're almost there. It goes fast. This is why I'm showing it to you this way. We don't have a 7 in this list, but we do have an 8. So we can do 8. Again, if we use 8, which is these 3, if these are used, then what's left over is a 9. Notice these two numbers add up to 1. These are the two numbers that we were looking for. Oh, I just realized you guys can't see any of the stuff I was writing. Ho, ho, ho. Let's go. Let's hop back over here. Let's hop here. Let's show this. Yeah, okay. I didn't realize that you guys couldn't see it. Dang, that was a lot too. We're just gonna have to do the best we can, right? I didn't say anything. Okay, I'm coming to answer those questions. So again, we did difference quotient. We just did f of x minus f of 2. Sorry, f of 4. Then we just kind of been working it down. Now we just factored the top. We found the two numbers, so we're gonna factor the top, right? So let's write this. This is the one that we're gonna rewrite. So that purple x we're gonna rewrite using the two numbers we just found. So we have this 2x squared. I'm going to do it like this, minus 8x plus 9x. And then that gives us minus 36. I'm going to use this technique called factor by grouping. If I look at the first two, from the first two we can factor out, it looks like a 2x. And we're left with x minus 4, it looks like, which is what we wanted. So we're anticipating another x minus 4 in the second half, so I'm just going to go ahead and write it. What can we factor out of the second two? It looks like we could factor out a 9. 9 times x is 9x. 9 times negative 4 is negative 36. So then we have a common binomial factor. So we can factor out this x minus 4 from both terms. If we factor out x minus 4, the common binomial factor, we're going to be left with 2x plus 9. Now we're ready to go back. So I'm just going to kind of draw an arrow. So we're saying that factors into this x minus 4 times 2x plus 9. I see the time. I'm about to let you guys go. Divided by x minus 4. Right? You should notice something now. So this was really a factoring example. 2x plus 9 is a simplified form. Probably an added statement that x cannot be 4. Let's see how do we do. 2x plus 9, right? Okay. Let's hop back this way. Let me check it really quickly. That looks proper. So then, when we finish, let me see. Yeah, we got 4x plus 9. Okay, let's just do it. 2x plus 9. Let's go with it. 2x. Hopefully, we didn't make any mistakes. Okay. All right, guys. I didn't really want to keep you beyond that. Today is what, Tuesday. So remember, we don't meet on Wednesdays. So we'll be back Thursday, same place, same time. Thursday at 3:50. Okay, guys. Enjoy the rest of your day. I'm available if you have questions. For those Alex codes, let me stop the stream. Give me a moment. Oops. Go back. That's okay. Okay, let me go here. Let me stop the stream.